Hello and welcome back to Just Code It. Today we're going to be taking a look at LangGraph State Management. Agent state can be extremely useful in LangGraph since it really helps with keeping track of your workflow and like retries and things like that, error handling, and also you can come up with some pretty clever ways to add value to your application using the state. The first example we're going to take a look at is right here. This state is a pretty common one where we track the task. It's a tracker. What we're doing here is we have a list of messages. I'm not sure if you've ever used annotate before, but essentially all it's saying is sequence of base messages is the type, and then it has this operator add. Down here, I specify what that means. Without this, it would replace with this, it depends. I'm not going to do that for all of them though. Task ID is just a string where it's a unique identifier. Retry, this is a number of retries that the LLM has used for a specific action. Last of all, we have is complete, which is just a Boolean that allows us to move on to the next node or take an edge. Let's just run that real quick. After completing the task agent state, we're then going to come down here and start creating some nodes. The first node we're going to take a look at is this initial node. In our graph, you can see that right up here, right at the top. What this node does is essentially just resets all the values at the beginning of a run, resets the is complete, resets the messages and the retries to 0. After that, we're then going to move on to the process node. This is the node with a lot of the actual processing being done. What this node does is, let's actually print this. I feel like typing that out. Okay, what the state does is it assigns the LLM. If you wanted to, you could pass in more information here. If the user selected a new chat or a new model, you could then pass it in here, not restart the whole application. We also are assigning the LLM here, printing the retries. Then if the retries are greater than 2, let's actually make this dynamic and do num, and then do num, and then we're going to set that to 2. Now we're actually going to make a dynamic input. So the user could say retry this 5 times, whatever. Now that's a bit more dynamic. And after that, it returns the retries +1, and then the invoke process retries, and then the state retries as the message. Else, it's just going to do a complete equal to true, and then message is going to be invoke, LLM invoke, task complete. Moving down a bit, we have our first and only conditional edge, which is essentially a decision maker. If you remember, what this edge does is it doesn't actually change the state. It just passes back an object based on the state. We're not making any changes to the actual state. We're using the state to actually make our own decisions, and then we're passing back our own method or our own values. Here, we're either going to pass back end or process based off if state is complete. So if state is complete, we go end, which takes us to the end node. This is just a LangGraph self-declared absorbing node. And otherwise, we take process, which we haven't defined yet, but we're going to call the process right up here, this process node process in our graph. And here we're just saying go to that if is complete is not true. Let's keep moving down and actually start creating our graph. The first thing we need to do for our graph is, of course, create that initial state using state graph. Then we're going to start adding nodes. We're going to add a node called init with that init task node, and then a node called process, like I was saying, with the process node. After that, we're going to make a pretty simple edge between init and process. After that simple edge, we have a conditional edge. How conditional edges work is you start with the entry node or the node that you're on. Process, we're on process. We pass it the method that makes the decision, which is the check complete, and then a mapping of the output to node response. Like I was saying, this returns either process or end. Here we're mapping process to process and end to end. I know that's not super fancy, but I actually prefer to do it this way because you don't make any stupid mistakes by calling something one thing and then calling a node one thing and then the edge going to that node or the decision making process going to that something else. I prefer to just keep them all the same unless there's a reason why I need to change them. After we create our graph, we're going to create this workflow check pointer, which is just a in-memory database essentially that persists some state across runs. This should only be used for testing, but they have a Postgres one and an async Postgres one. You can take a look at those, but this is just way easier for development. We compile a graph and see if we messed up in any way. Like always, we're then going to visualize it. Now that we're done creating the graph, we can finally run it. To do this, we just do the initial state and then pass it into the task graph and invoke off of it with the initial state. When we do that, our response should be a list of messages. And then we have the max retries, which is n+1, which is 3, and then is complete true, and then task ID, which is hard-coded. Now let's also run it with debug, but I think you will probably want to run it in an actual console because, yeah, it's going to have a lot of output. But here we can actually see what's going on a bit easier. If you go all the way to the top, we have that beginning stuff, but we have that initial state. Then we come down here. We see step 1 is complete false, retries 1, retries 2. Essentially, this is outputting all of our information every single time it changes within the state. And then all that added up creates our final state right here, where we essentially just iterated over itself for n number of times. It's not super fancy, but you can imagine what you can do with this kind of functionality though. The next example we're going to do is one that is a bit more complex, where we're going to interact with two objects or two states in a way. In reality, they're just Python classes, but you can think of them as states in LangGraph. This is the graph we're going to create where we have subtasks and summaries with the complex agent state as the overall state manager, and then the subtasks taking care of the state within each tasks. Let's first work on the subtasks. Here we just have the name and the result, which is a dictionary of string and any. Nothing too fancy. And then for the actual state, we have a lot of our typical ones like message, which is a sequence of base message and a add operator. We do not overwrite them. Then we have subtasks, which is a sequence of subtask state. I hate these words. And it's also an add where we are going to essentially add subtasks. And then overall summary, which is the overall summary that we come up with. We only have two nodes. We just have the subtask node, which is right here. As you can imagine, this creates the subtask. What we do here is initiate that subtask node. What this node does is it instantiates a new subtask, or within here, you could essentially create subtasks. But right now we're just creating one, but I guess for fun, we could also do 2. And then here we created 2 subtasks. You could imagine this being a process of creating tasks that create a list of tasks and then passing it to our next state. As always, when we return something from a node, we need to make changes to the state, or we need to return the state and make some changes to it. What we're doing here is we're making changes. We're adding to these subtasks, and then we're adding a message, AI message subtask added. After generating that subtask node, we then create the summary node. I'm not doing anything fancy here because it's essentially just the flow that is important. What we're doing is just joining all the subtasks, and then overall summary is set to summary, and then message is the AI message with the content set to summarized. You might have noticed we do not have any decision-making nodes in this. We will not have any conditional nodes in this graph, but that will also make it really easy to create this graph structure. Node is just going to be subtask and summarize. And then all we're doing is going straight through it, which is subtask to summarize, summarize to end, entry point subtask, and then compile. Run that. Oop, we did not run any of the above ones. Let's go through it. We're then going to print the node, or print what it looks like, pretty graph. And finally, take a look at what it actually looks like when it runs. We create that initial state, which is message, human message, run complex task. And then example, this is 2, this is example 2, complex task, and then invoke the initial state. Let's see what happens when we run this. Set debug to true for one of these and rerun it again. Here you can see the path. I mean, there's not really a lot going on in this graph. Then the final state, which let's make this a bit bigger for everybody. The final state, which is the human one right off the bat, and then 2 AI ones because we created 2 subtasks. And our final subtask, or the summary of our tasks, is just the dictionary of our subtasks. But if you wanted to essentially, let's say, grab the data from this and then pass it into an LLM and say summarize, then you could actually get a good summary for this subtask area. Then we have this subtasks, which has the subtask name and task ID, and then the data. These could be essentially do this task or go to this website, get this data, go to this website, get this data, and collect a bunch of things and get the results, and then go to the overall summary. Later on in future videos, actually coming up pretty soon, we're going to start doing things like that where we're putting all this together and creating some cool apps. I'll actually show you a little sneak peek. I mean, most of these are not done, but some of them are. We're going to do a LangGraph stock agent, travel agent, financial investment agent. That one I've actually gotten pretty far along on. And then legal document analyzer will be fun. Some of these I'll probably kick because I'm not that interested in it. And then the deep research one will be fun. If you want to come up here and take a look at some of these apps, they're all in there. I haven't really worked on them that much. Those are what we're going to start doing. And I think I'm going to start throwing them in here. I don't really know if I'm going to do this persistent model. Let me know what you guys think about the flow of this. And if you have any suggestions, if you want me to get rid of streaming because we kind of did that with agents, or models because that's pretty Googleable. Tools will actually be pretty interesting. MCP, I'm sure people will love. Context, memory are important. Human in the loop. And these are essentially just design patterns for agents. The RAG, multi-agent, and human in the loop. Multi-agent, I think, is going to be kind of the way of the future, honestly, because can't use big ones for everything. But if you come to the GitHub and take a look at the code, there's a bunch of information, and then just leave me comments for what I've messed up on or what you would like me to cover next. Also, I'm really sorry, my GitHub, I'm horrible at keeping clean repos when I'm just doing side projects. Essentially, it just follows the naming convention of the videos with the part that will line up with this. And then everything else, I mean, there's like 1,000 files in there. I typically try to clean it up right at the end and put an archive folder that's hidden or that's ignored with like past files that I guess you wouldn't be able to see on GitHub, but I'm sorry for that. I don't really have a good method yet for doing all this because I do it really haphazardly. That is it. Hope you enjoyed today's video, and I'll see you next time.